Hello and welcome. My name is Quavel and I'm a Minecraft Bedrock Redstoner, add-on creator, and now I can add World Builder to my list. Recently I have been busy finishing my puzzle map, the Mortland Mystery. I want to give you a bit of a tour and show just a few of the redstone mechanics I have used. Today I will start with Mortland Fort. This was my first puzzle area, which I started building years ago. It's quite large as there is plenty of rooms to navigate through, but its size is mainly to allow for plenty of hidden redstone contraptions. Once you have found your way in, you will find yourself in the courtyard. I'll pass through the storeroom and the kitchen into the mess hall. Here you will find the colour wheel puzzle. The idea is that you press a button and the highlighted colour block revolves to the next colour. I'll give you a little hint, it's not this button, you have to find it. As a little point, you notice that the blocks used for each colour are custom design. I originally used concrete blocks, but then I realised that some players may have problems distinguishing colours, so I've added shapes to them. Here's my prototype. I press this button and the colour wheel moves to the next colour in the sequence. It's a little slow to react, but this is not important as the actual button is not directly next to the wheel. I should point out that this build was from a few years ago, which is not my best. At the back is a belt of 8 blocks pushed by 4 pistons, each controlled with redstone dust and repeaters. I press the button and the 2 vertical pistons fire first, and when they retract the 2 horizontal pistons will fire. One of the moving pieces is a redstone block. The position of this block is mapped through to the different layout of the 8 blocks at the front. This mapping makes it bulky, having redstone here makes it bulky. There was so much clutter which made it difficult to use, especially when adding more redstone to determine when the puzzle was solved. But I made it work. Because it is working, I didn't change it in the original map. But I have managed to redesign it to a far simpler structure. Again, same principle. I press the button and it moves to the next colour in the sequence. From the back you can see it's a lot more compact. It's now using 5 pistons, arranged to ensure the wheel layout is the same both at the back as the front. The redstone block does not need to be remapped and directly powers the piston at the front, pushing the colour block forwards. Now rather than using redstone dust to control these pistons, I'm relying a lot more on using observers to control the timing. You can see what happens when I press the button. So the mechanism is a little more complex to rotate than the 8 blocks in a belt, but it does allow for the shape to remain constant front and back. First, this bottom piston pushes up the left side. 2 ticks later this left piston is powered, and in turn this piston has a redstone torch which inverts the power to the top middle sticky piston. While this top sticky piston is extended, the left piston cannot move, but the moment the power switches, the top middle block is pulled up and the left piston can push both these top blocks. When the power drops, the top piston pushes the new block down again. In the meantime, there is a chain of 2 observers looking at the first piston, which gives power to the right side piston. Once the initial piston has retracted, this piston can move, which triggers another observer chain to the last piston at the top right, pushing the last 3 blocks down. One additional change was to shorten the input pulse. As some blocks will move when the pistons retract and the buttons remain powered for 10 to 15 ticks, this would force an unnecessary delay. I've added a little circuit that creates a 4-tick pulse when the button is pressed. The design is a lot more streamlined, a lot cleaner, and of course it's very easy to detect the location of the redstone block, and thus far easier to determine when the puzzle is solved. One puzzle uses a scoreboard mechanism. The player must enter the correct combination of scores to complete it. Each bar has 2 buttons, one to make the score go up and the other to make it go down. From my prototype you can see that this contraption does extend a few blocks back, but my target was that it should be no more than 3 blocks wide, so I could place them side by side. As I had the space behind, I wasn't worried too much about trying to reduce the size of the redstone machines, but I did want them to appear compact from the player's view. The score value is stored in a dropper and hopper combo. The hopper is constantly powered except for the moment when the up button is pressed, and the dropper is powered momentarily by the down button. The hopper is holding the score using a range of 0 to 5 non-stackable items. When read by a redstone comparator, this neatly converts to a signal strength of 0 to 15 in steps of 3. If we follow the redstone dust on the crimson wood from this comparator, once it reaches 1, 2, 3, this feeds into the repeater which powers the redstone lamp at the front. If we continue, 4, 5, 6, this is picked up for the next lamp. This continues 7, 8, 9, and then so on till we reach 15 at the top. As we need to determine when the correct score is entered, the redstone on the cherry wood is for detecting these values. This one is connected to lamp number 1, so will be powered if we have a score of 1 or higher. The signal will then turn this redstone torch off, and on the other side we are picking up the signal from lamp number 2, so it will be powered if we have a score of 2 or higher. This connects to the output of the redstone torch earlier. In effect, this redstone dust powers off when we reach a score of 1, but on again when it's 2 or higher. So at the moment the score is set to 0, so the redstone torch is on, but when I set the score to 1 it goes off, and this is demonstrated by inverting the power into this redstone lamp. If I increase the score again, then we power the redstone dust again and the lamp turns off. If I wanted to detect a score of 4, the principle is the same, but rather than the values being side by side, they are one above the other. So this uses a slightly different layout. Obviously, to detect a score of 5, I just need to detect when the top lamp is lit. Likewise, for a score of 0, I detect if the lamp 1 is not lit. I'll briefly fly around for a bit in spectator mode so you can see some of the large areas devoted to redstone. Some rooms are empty and some are quite crowded. I chose to build the fort walls before adding the redstone, so I made it particularly large to allow the space. One feature you'll see on this map are these barred doors. The custom bars emphasise to players that these doors are not meant to be opened. Most of these barred doors are hiding redstone contraptions, and it was a simple way for me to gain access if I needed to reset puzzles. There are some more physical challenges in each area. Here we have a room which I call the training corridor. You stand on the pressure plate to start the action, and then you must jump or crouch to avoid the obstacles. Unfortunately, I'm not very good at this. For this machine there is a timer which runs for about a minute. I'm not impressed with the circuit I've built here. It is messy and I've made far cleaner methods since. I will cover these in another video soon, so I won't go into the details today. But what I can show you is that once this timer circuit is active, this is powering a pulse, and this runs down the length of the corridor. The series of pistons are pushed in and out at different intervals, creating the obstacle course. I also have this shooting gallery. It's a very simple redstone mechanic that lights up depending on how close you are to the bullseye when you hit the target block. If you didn't know, the target block lets out a variable redstone power depending on where you hit it. Around the edge gives a lower power output, and dead center gives 15. The redstone circuit looks messy, but it's a simple case of redstone dust spiralling upwards and branching off at key intervals until it reaches the very top, which needs the full power level of 15, a bullseye. The principle is very similar to the scoreboard earlier, but I wanted to use irregular power levels of 1, 6, 10, 13 and 15, so we have this very irregular shape. As an added note, I did try the same build using comparators to test each power level. This was definitely a cleaner structure, but it's much larger. It would be a better method, however, if I was only lighting 1, 2 or 3 lamps. Now here we have a very simple puzzle that requires the levers to be toggled to the correct combination. As a visual aid, I've also added some custom blocks which highlights which levers are on. A quick look at the back shows its simplicity, but as with a lot of the other redstone contraption I made a few years ago, it's still more complex than it needs to be. So here is the recreation of the lever wall that I just used. There is 8 levers and each has a sticky piston connected. Some are directly connected to the block behind the lever, while others have a redstone dust so that piston is brought forward. At one end of each row, it is powered by a redstone block, and for the circuit to complete, each block must be in the correct position. The result is that some levers push blocks into position while others push them out. So if we turn this lever on, we complete the top row circuit and it reaches the end. And the bottom row uses the same principle, so we apply a simple AND circuit to both. So if we complete all levers into the correct position, the lamp turns on. Any lever in the wrong position and the lamp is off. I remember I was very impressed with this simple logic when I created it, but it does have one problem. The levers need to be spaced one block apart. When I later used a similar lever wall in another area of my puzzle world, I devised a far better solution. The levers can be placed closer, the redstone is far simpler and everything is more compact. Behind every lever that you want to be switched on, place a redstone torch. Behind all the others, place a redstone repeater. Then you connect all these with redstone dust while combining the circuits of both roads together. When all the levers are in the correct position, then there's no power coming into the circuit. To show this, we'll invert the output power into this lamp. Any lever in the incorrect position will apply power and turn the lamp off. As a minor comment, I have used repeaters to make the circuit look tidy. If you're building this on survival and cost is an issue, then you can simply replace them with redstone dust. And thank you for watching. There are 3 more areas of this map that I intend to cover: the manor, the village and the mountain. So please subscribe if you want to be alerted when they're available. And if you want to play this puzzle map for yourself, then the details are in the description. Goodbye.